Zan. Our next topic is freeze-thaw processes in permafrost, which will be presented by our colleagues in NGI. So Lee, the floor is yours. We can see your screen perfect.
Hear me now?
Yeah, we can hear you.
Okay. Yes, my name is Le. I'm working at the Norwegian Research Institutes as researchers. And in these presentations, I've been asked to present about our capabilities to physically and study freeze-thaw processes in permafrost. Okay. Sorry. Yes. Yeah, the interest in permafrost in the last few decades have increased considerably because of climate change. As you can see from these pictures, erosion, settlement, stability is a huge problem in Arctic areas, permafrost areas, and also in high mountain areas where there are extreme weather. In these presentations, the focus is on permafrost, but I will start to give you an overview of our research facilities in NGIs, which is the geotest site, and then talk very briefly about physical modeling of freeze-thaw processes in permafrost. And in the end, I will go briefly in 2 examples of our field testing in permafrost. The geotest site facilities that is managed by NGIs located in Norway, in Svarberg, include 5 different geotechnical sites where we can test different geotechnical solutions in different soil conditions. We have a soft clay site and a silt site, which located south in Norway near Oslo. We have a sand site and a quick clay site, which is located in middle of Norway near Trondheim. And also we have a permafrost site, which is the main interest of these presentations in Svarberg here. In addition, we offer a research facility for full-scale testing of snow avalanches here in Norway. And when we talk when we think about field testing, we think a bit more broad, more than typical physical modeling in the lab or in the centrifuges. I'm just present here some example of the type of field testing that we've been conducted in our test sites. Here we test, for example, a sampling method, which is the Geolab sampler for undisturbed sand sample. We also conduct full-scale testing of pipes who are capacity, for example. We test also at the moment a lot of interest in testing different geophysics methods, non-intrusive ground investigations, so to say. The pictures show the electrical resistivity tomography measurements in one of our sites. And then we also conduct classical full-scale model tests, for example, slope stability, where we actually make a full-scale slope in the fields and install different equipment for observation, in this case, freeze and thaw slope in cold climate, not in permafrost in this case. This slide will just show a bit about the motivations of physical modelings of freeze and thaw processes in permafrost. By definition, permafrost is soil that have been frozen continuously for 2 consecutive years. And the reason that there are more and more interest in permafrost studies because climate change have caused global temperature rises and intensify permafrost thawing. And the thawing that is a big problem in permafrost because permafrost loses its strength. And that causes erosions, settlement, stability problems for infrastructures that is built in permafrost. And normally that is very much in permafrost area like Arctic area, oil and gas industries have a huge infrastructures such as pipeline and then other infrastructures to support oil and gas productions. And then they have invested a lot of money in this kind of problem, research in this kind of problem. With physical modeling, we can study permafrost in small-scale centrifuge tests. We can also study in larger scales laboratory tests, as shown in these pictures from this from a study by Harris et al. In 2008. But the main focus of this presentation is field-scale tests, which I will go into detail in the next slide. The field-scale test the example of the field-scale test that I will show now is pies in permafrost in Svalbard, and the pictures on the right is the test site that we have in Svalbard. The aim of the study is to determine the impact of thawing land, coast, and subsea permafrost in the Arctic. And as the pictures, this picture shows, because of thawing of permafrost in Svalbard, new buildings in Longyearbyen, which is the main town in Svalbard, is now built on steel pillars. And the testing program that were conducted in our test sites involved several pies, which was set up in the plain east of UNIS, which is University Center in Svalbard. The user group in this case is University Center in Svalbard and the Norwegian Technical University. And it is not part of transnational access. It was conducted as part of another European funded projects. And these pictures shows basically summarize the test. First, 3 pie of 33 centimeter each were installed in pre-draw borehole, as the pictures on the left shows. And then we set up a triangular shape load frame of steel. The shape is induced by a concrete slab, each of 1.4 tons. And then a lot of different monitoring equipment, like a load cells, wire displacement sensor, and temperature sensor were installed. The test is still going on. It started in March 2020 as part of a PhD study of Xixiang Yu from Norwegian University of Technologies, and it's going to continue. And the purpose of the test is to validate current bearing capacity and settlement theories, especially captivity expansion theories, to back calculate thermo-hydromechanical model that have been developed in the user group, and to develop a robust cost-saving pie design framework for future design for sustainable infrastructures and building in the Arctic. I will move now to very briefly another example of a very different type study where we actually use geophysical survey to study Arctic landfills. In this case, in the study site which show in these pictures, we use electrical resistivity tomography to measure measurements and induce polarization surveys to assess the performance of Arctic landfills. And the study site involved active landfill near the tower of Longyearbyen and 2 potential new landfill near Longyearbyen and Barentsburg. And the pictures just show how the study carried out, much less complex than the PI study, because it is non-intrusive methods. And basically they install electrodes in the ground and measure the conductivity between different electrodes. And with the data, they can come back and process in the process with different methods to kind of predict the top or interpret the top of the permafrost and tops of bedrocks by different methods, and put it together with borehole data, field observations to construct geological interpretations, as shown in the pictures. The main aim is to investigate to which extent permafrost acts as geological barriers for landfills and how this barrier characteristics are impacted by climate change. And with that, I finish with my presentations, and thank you for listening.
Thank you so much, Lee.